Welcome to Are You Ready for Cloud Native Java with a hyphen. And if you want to know why there's a hyphen in there, you can talk to Graham afterwards. We're not going to discuss it.
A bit pedantic.
Pedantic, yeah. Well, we'll see where this goes. So I'm the one not being beamed up by a UFO. So my name is Steve Poole. I work for IBM. I'm a developer advocate. I'll put the coffee down. I'm a long-term Java developer, JVM developer. I've spent almost my whole career at IBM, which is a long career, working on JVMs of all sorts, other bits and pieces, lots of open source. And I'm going to be representing the JVM in this story. And Graham?
So I'm Graham Charters. I'm also a developer advocate in IBM. Again, for far too many years. Largely in the app server, but also doing various innovation projects and other things. And I'm going to be talking about the stuff that runs on the JVM.
Excellent. Right. So apparently we have a quiz.
Yeah. So we thought we work for quite a large company, and large companies provide education to you in the form of. So we've just been through GDPR education, which is very important. And what they usually do is they teach you about something and then they have a bunch of questions. So we're going to need a little bit of audience participation in this. But we thought we'd do it in the style of those kind of education things or certifications that we have to go through our company. We're going to share the joy. So we'll start with a question which will hopefully, I guess, give you a feel for what we're talking about, and also as a kind of gauge your views at the start, and we'll gauge your views later on with other questions. So you've been deploying Java applications for years, and you want to move to a cloud-native approach. Do you? Oh,
you're gonna
use the clicker.
Yeah.
A, decide cloud-native is so different you should throw everything out that you know and start again. Hands up for A.
Who wants to rewrite? Okay.
Couple of you?
Yeah.
Okay. B, you decide cloud native is just a storm in a teacup, playing on words, and hunker down till the clouds have passed. Who wants to do that?
Who's going to ignore cloud native because it's going to go away?
Yeah, it's just a flash in the pan.
Okay.
1, excellent, thank you.
Yeah. Well, that is a good sign. Okay.
Yep. And finally, the last one. You understand how modern Java runtimes let you reuse and extend what you've already been doing in order to create new cloud-native applications. Who wants to do that? Who thinks that's the right answer?
Good.
Excellent.
You're in the right room.
Okay, so we can stop now, I think.
Okay. Yeah, we're done. Thank you. Okay. All right. Oh, yeah. No, I'll use my finger. I'm used to that. So, the interesting thing. So I'm going to talk through now about what cloud is, but not a technical story, right? Because it's not what you think it is. So we talk about cloud native. You know, we don't talk about server native or things like that. There's something special about cloud. So what is special about cloud? Well, partly we made a promise. Cloud, those of us providing cloud made this promise, and the promise to the organizations were, you can see the words, a virtual dynamic environment, it's infinitely scalable, it's always there, and you don't have to spend capital using it. It's an expense. You can just buy it, you hire it, and you throw it away, right? And it's this, hey, take your code, run it on somebody else's machine, and pay for just what you want to use. You know, what's not to like, right? So effectively, that gave something that, as an industry, we've been promising for a long time, which is compute on demand, right? We've always been saying, one day we'll have this system where you can do this, right? And well, we're here. We have compute on demand, okay? Now, the weird thing is that it turns out that this changes the way that we think about computing, and we now have to think actually less about technology and more about money. Because this compute on tap thing we've got, which we're trying to, has its own peculiar behavior, and it's almost all focused on economics, right? Because of, as you'll see, is in the end of the day, cloud economics is more in your face. The economics of compute on the cloud has a much closer relationship with your economics. Okay, so we have compute on tap, which is great, and then with that comes meters, because what actually happens here is as soon as we start telling people about I want to go buy some storage, I want to go and buy some disk or some network, okay, That's money, isn't it? Right? So what's happening with cloud is it's making the relationship between the compute that you're going to use and real money that much closer. Kick something, yeah. Right. And you know that as soon as money gets involved, new people wake up, right? And when you've got this measurable connection, right? I buy RAM, it costs so much money. I buy bandwidth, it costs so much money, right? Right. Suddenly, right, people start going, how much are you spending? Right? You're more measurable, right? More focus on money. So here's the equation. Compute equals money. And in the compute world, mostly it's gigabytes per hour. That's mostly what we buy. We buy memory. That's the biggest thing. It's not the only thing we buy, bigger thing. So basically, memory is now money. So basically, you'll be doing this. Right? Dash XMX $100. You think about the consequences of that, because that's the relationship that we have now given everybody. Right? So when you go, I want to increase the amount of I want to increase the size of my heap because something's happening, suddenly your accountants are going, oh, hang on a minute. So how many servers do you want to run? Oh, that's, you want to increase it by $5. Well, that's going to cost more money. How are we going to pay for it? That's the relationship that suddenly is in your face, okay? And people are measuring it, right? And it gets harder because if you think about how your cloud application is constructed, right? What's it on the cloud for? It's on there for it's always available, it responds to demand, and those sorts of things. So how do you, when you have some access of time and you have some demand that comes through, how is your application going to be designed to deal with that peak load, right? Right, which I think is what I said there. So one option, put your monolith and your big server in the cloud, right? And so you imagine that's all your capacity that you've already bought, and there's the demand, the blue line, the white line. So basically, that lot, the red stuff, is wasted money, isn't it? Because you bought that and you didn't use it. So that drives our behavior. So we think about how we design applications to now in the cloud to deal with that problem, right? So we now realize that we need smaller units, more compute units with shorter line scale and quicker to start, right? And of course, that makes it a little bit cheaper, but actually nowadays we're down to really tiny units, aka things like microservices, because they can fit the demand model better. Okay, so that's great. But there is a part of the picture that's not easy to see on this. So microservices, small units, changing your application to fit into the cloud is driven totally by economics, right? But the other part of the economics is startup time. So how long does it take your application to go from nothing to being able to deal with the response, right? How long? Now, traditionally, if you look at the way that you look at old benchmarks for, spec JBB or things like this, we always competed on this axis being forever, and the amount of time that it took you to get from nothing to full function was ignored. We just went, that's fine, right? Because we don't care about that bit. What we care about is the throughput. Okay, so that slope could be as long as it was. We were taking costs, runtime costs from here and pushing it into startup costs. And one of the consequences is we tend to get these humps at the start of the benchmark, okay? Okay, and you go, well, that's okay. Oh, did it again. Right, right. But if you think about it, in a cloud point of view, now you're introducing delay. So if your cloud application, if your microservice takes a long time to start, then you've got to have more around because you've got to respond to demand. So how long does it take to start, etc. So you may go, I need to have some stuff sitting around just in case, costs you money, right? So that's the lag. And the second thing is you're buying RAM in tiers. You're going to Amazon or whatever and you're buying a tier. So if your hump takes you outside the capacity, the maximum of that tier, you're now on the next level. So now your microservice, or whatever you deployed, is running in another tier, but actually only for a short period of time, and then actually you'd be running a lower tier, but you can't change it. So again, wasted money. So in the cloud, what we need is this sort of performance profile. Very, very fast, nothing to working, and no humps, right? So that you can tune your costs to the maximum. So you're no unexpected loads, right? So there we go. So small runtime footprint. I'm worried about blocking things. Small deployment sizes. Fast applications, because if it takes time, it costs you money. Oh, and by the way, you don't want these things to be ticking around, because if you're paying for CPU and you've got something that's idle, right, that costs money, right? And if you're a cloud provider, it costs you money to run these things, and if you've got something that's just ticking over, it's still costing you times, okay? So what does that mean for Java and the JVM? So, busy chart. Your application's running in this remote, constrained, metered environment. Very precise limits on your usage. All these usages are bounded. If you go beyond that, it costs you more money, right? You'll be paying for it. And the people who are paying for it now understand the relationship much more between your application and the costs, right? So they're going to measure it, right? And the consequence to you is your application is going to go on a diet because you've got to reduce all sorts of things that you didn't need to do before. And we need to change to JVM. Okay. So the first question is, given that we need a JVM that can deal with all these aspects and can run in the cloud and startup stuff, like, the first part of our next quiz is cloud so different that the JVM is no longer relevant? So who thinks that we should stop using JVMs and just go do Node? Anybody? Anybody willing to give it a... No, okay.
Good audience.
Good audience, yeah, okay. Well, what about maybe? Can we achieve what I've just shown you, those new profiles? Can we do it just by retuning the JVM? Okay. Or maybe we need to do something else. What do you think? Do you think we can get, with what we've got today, the current technology, do you think we can muddle through? Anybody think we can muddle through? Yeah, you don't know the answers, do you? Okay. All right. And is cloud so different that JVM is no longer relevant? And the answer is no, because not all JVMs are the same. So let me introduce something that we recently open sourced. So IBM has this JVM called OpenJ9, and it's been around for a long time. It's got a big pedigree, and we open sourced it. We open sourced it for the same sorts of reasons that Mark Reinhold talked about in his keynote, which is innovation and speed. Right. So we want to share this. We've been open sourcing it so we can share it. It's on Eclipse. It's available under multiple licenses. You can go get the binaries. So you can go to Adopt Open JDK, which is this community website, which has got a whole bunch of different binaries. You can go get Hotspot, of course, and OpenJ9 and 8 and 9 and 10 and 11 and all the way through to whenever it stops. You can go download it. Or you can go get Docker images of the same sorts of things, right? It's available right there, right? Okay. So the reason this is a good platform for us, for the cloud, is because it's got one of these inside. No, not really. OpenJ9 pedigree is from an ME space, tiny, constrained devices. Right? So what do you got? Java ME, so you've got your phone, you need small footprint, you are both on disk and in memory time space, because phones don't have much memory, do they? In fact, some of them, they just have ROM, so you have to deal with that as well. Fast startup. Your Java application on your phone, you press the button and it takes 3 minutes to start. That doesn't work well, so you need to have really fast, right? And your game should not play better the longer you play it. Your application should get there, be jitted, and be ready as soon as possible, right? You don't want something that you have to wait for it to for the performance to improve, right? And basically, if I replace ME with cloud, I get pretty much the same characteristics, right? It all matches, right? So what are the results? So we open sourced this not that long ago to share this with everybody. So what can we do? So startup time with OpenJ9, 30% faster than Hotspot, right? So you've got Hotspot, OpenJ9, and this is this operating mode. So you can do this now. You can go get J9. You can take your application, put OpenJDK with OpenJ9 under it, put the right parameters in. You get 30% less, 30% faster startup time. But same thing also gives you massive improvement in memory usage, right? Pretty much everybody, and you can go look on Twitter and you'll see lots of people trying this out. You can now get your application to use less memory just by switching your VM. Right. Now, your mileage will vary. Not everybody will get 60%. Some of you may only get 40%. Some of you might get more. Right. So think about this. So when I have this nice little picture of throughput and time, etc., that we talked about at the beginning, and I wanted to meet that curve, well, that's what Hotspot achieves today. Right, this is real data, real benchmarks. This is what Hotspot achieves. If I do OpenJ9 with OpenJDK 9, the blue line, okay, it's not perfectly up, but it's up faster, right? And it's steady, it's there quicker. And in fact, if I'm willing to spend some CPU, I can get this profile, because this has an AOT activity in it as well, so I can actually get my application starting almost instantaneously. But because it's AOT, so I've done all the compilation up front, I'm not doing any jitting as it's running, right? So it can't get any better, right? So there's some profiling going on that you don't do anymore, so you can't achieve the throughputs. But that's a point-in-time statement, right? That's just right now, right? So I think the JVM saves the day. So I'm lauding OpenJ9 because it's there now. I'm not going to say that Hotspot is never going to do this, but OpenJ9 started from a different point with the design characteristics that fit, and just by moving it into this cloud environment, we get those sorts of benefits. So I think we've done. Do you want to do the quiz?
Can do, yeah. So the question is, where's the question gone?
Well, that is the question. I don't know.
It's not showing.
It's PowerPoint. There we go.
It's gone weird.
Yeah.
You're going to get all the answers ahead of time now. So, Cloud Native Java, are we done then? So is it all just about the JVM? So yes, nothing to see here, move along. Or not really, still need to re-architect my application potentially. So who votes for A? We're done, it's just the JVM.
Have I sold you on cloud and you don't have to do anything? Oh.
No takers. Either that or they don't want to stick their hands up. B, not really, still need to re-architect my application. Oops. Yeah, a couple of them, that's good. No, actually, Cloud Native introduces some new challenges. Well, it's probably a bit of B and C, I think, in my opinion. So, it's great, all the benefits we can get out of the JVM, and getting the better profiles, better memory usage and so on, faster startup time. But if you still stick something on top of that that's pretty darn huge, and then deploy lots of instances of those things, then you're going to have you might be getting some JVM benefits, but you're going to outweigh those with what you've just put on top of that JVM. And I think I've just likened your JVM to an ant.
Okay.
Sorry about that. Although I think I'm talking about my stuff as a rock, which probably isn't particularly nice either. So, who here thinks that application servers are the right answer for Cloud Native? Who here uses application servers? Yeah, quite a few of you. Okay. Do you tailor your application server environment for the particular deployments you're doing? Nope, no. So application servers, I think, got a bit of a bad name over time. And the reason is, if we go all the way back to 1998, with Java EE particularly. So Java EE came about, it started off as a very, very small project, and then over the years, new capabilities were added in. And there was a kind of realization probably in the mid-2000s that things were getting quite large. I know the app server that I work on was quite a large download, used a lot of memory just to start.
Famed for it, I think, wasn't it?
Pardon?
Famed for it.
Yes,
Yeah.
thank you.
Yeah.
And I'm going to hopefully dispel that. And so around the around 2009, we came out with EE6, which said, well, we'll break EE up into profiles, but of course, and came out with web profile, but web profile was a set of specs kind of for web applications, not necessarily microservices and cloud native applications. And also we found nearly invariably that when we talked to customers about running on just this, they said, well, we need just this one thing that's up in here. Or they said, well, actually, I just need servlets, so you're giving me more than I want as well. And so, and of course, this has continued with EE8, for example, which added a couple of new specs and enhanced some of the existing specs. And of course, EE certification requires you to support all of these things out of the box, which kind of tends to push you down a bit of a monolithic view of the world. But what a number of the app servers have done is either define new profiles, or, for example, in the case of Liberty, and I'll also describe what Wildfire's done, is they've broken down the capabilities into just that, capabilities. So you can build runtimes that are tailored to fit your application needs. And this is important, as Steve mentioned, about footprint and memory usage and so on. If you're going to deploy thousands of instances of an application into your cloud environment because you've taken a microservices approach, if you deploy everything, all the capabilities, then you're paying a tax every time on every instance of those things, and that just doesn't scale economically. So, for example, Liberty, you can choose each of the individual capabilities. So, in this particular example, we're going to start a server which just has JAX-RS2 and OpenAPI. So, maybe the application is just exposing a REST service using JAX-RS, and then using OpenAPI, which is the most recent form of. If you're familiar with, anybody familiar with OpenAPI? Oh, that's a better number than most sessions I do. Good crowd. Anyone familiar with Swagger? Okay, more hands. Okay, so Swagger was contributed by Swagger Inc. to the Linux Foundation and standardized. OpenAPI 2 came out in 2014. OpenAPI v3 came out in 2017. So you can just think of OpenAPI as a standardization of Swagger. So it's a way of describing REST APIs. So in this server, we're going to implement a REST API and then have a description of that REST API so people know how to call it. An equivalent in the JBoss world with Wildfly Swarm, they have the concept of fractions. So a fraction is essentially a capability you can define in your build. So here, again, maybe the application is using JAX-RS to expose a REST API and then using Swagger to describe that API. All right, so I'm going to hopefully do a demo. And I think I probably need to switch to... Yeah, it's not going to show up on there. Let me just switch to mirrored. That's probably a little bit small. There it is. Didn't give me my mouse pointer. And so I just want to show an example just to give you, because maybe some of you are a bit skeptical that you can get small application server runtimes. So let me just... Should have done this before I resized the window. All right, so I'm going to just use this script actually just runs a Maven archetype to generate a sample web application. So this is going to be using OpenLiberty. And what I should do is switch the Wi-Fi off so it doesn't try and talk to Maven Central. And do that again because it'd be much quicker. All right, so I've now got a generated simple web application project. So I'm going to build that. And so this, if I remember rightly, it uses JSPs. That's all it configures into the server. And I'll show you the size of the server package afterwards. Actually, let me just show show the server configuration because I'm going to edit that. Can people see this okay? Yeah. All right. So you can see this server's just configuring in JSP. So that's all it's going to build into the runtime. So if I just have a look at that, you can see that's 28 point something meg. The full package, full Java EE environment is, I think, around 100 megabytes. So it's cut it down to less than a third. And I happen to know that this application doesn't use JSP, so why somebody chose to configure that in, I don't know. Oh, I'm getting ahead of myself. Still ahead of myself. There we go. So I'm going to change it to just use servlet, and if I then build it again, you can see it's now only 22 meg because we've taken out the JSP capabilities. And just to prove that it actually works, we can now run that server. And it's a very friendly service. Okay, so that's just kind of get the point across that there are server environments that let you pick and choose the capabilities you want, which means if you're deploying lots of microservices, you can slim down the runtime and tailor it to exactly what you need. All right, so leading the witnesses. Quiz question, test question.
Yeah.
So you've been deploying Java applications for years and you want to move to cloud-native approach. So this is a revisiting the first one to see if everyone gets it right now, although most of you got it right anyway. Decide cloud native is so different you should throw everything away. Decide it's a storm in a teacup, or understand how modern Java runtimes let you reuse and extend the capabilities you've had for many, many years to build cloud native applications. So votes for C.
C, yes.
Anyone with your hands not up? We still need to do more education. All right. So that's great. We've talked about runtimes, but that's only part of the story. So if you think about you're creating, you're now with a cloud-native approach going down a microservices route, and maybe you've aligned teams around those microservices, so you're now collaborating across teams to communicate, to share communications between microservices and so on. This all introduces new challenges, and how do you address those challenges? The runtime is not going to, or slimming down the runtime is not going to help you work better with teams. It's not going to help you handle some of the challenges around the fact that you've now got lots of microservices collaborating with each other. Potentially some of those are not going to be available for a period of time because maybe an upgrade didn't quite go right or something like that. So you end up with resiliency problems you need to handle, and there are also management problems, new management challenges. So how do we address those things? So is there anybody who's here is familiar with MicroProfile? Okay, all right. So if you're familiar with the kind of Java EE world and how that's evolved, what MicroProfile is it a number of vendors got together and also a number of user groups and user communities, so the London Java community and Sue Java, for example, and said Java EE is a great set of technologies, but for modern cloud-native microservices, we need to maybe build on a small set of those Java EE capabilities, but add new capabilities to address the new challenges. And so I like to think of this in terms of kind of three sets of capabilities that have been defined in MicroProfile. So MicroProfile, it started out as a collaboration, went to the Eclipse community under Eclipse MicroProfile, and defined specifications, and then vendors that participate there then provide implementations. And I talk about these things in terms of three sets of capabilities. So the first set of capabilities is just, well, you're probably going to want to write REST services because you're doing microservices communicating with between each other to essentially realize some kind of application. And MicroProfile said, well, we already have in Java EE a set of technologies that are useful, so we want to cherry pick those out. We don't want to bring the whole of Java EE across and say that each vendor needs to support all of those capabilities. So let's just bring some things across, for example, CDI for doing component models. So if you use Spring, then you're familiar with the concept of beans and dependency injection and inversion of control. That's what CDI gives you. You're probably going to want to be flowing JSON payloads, so JSON-P gives you JSON processing capabilities, and then JAX-RS, as I've mentioned before, for doing REST services. And then what the MicroProfile community did is said, well, those are great technologies, but we're kind of missing something. We need a nice, simple way of being able to call REST services, which was kind of missing from JAX-RS. And so the community defined the REST client, which gives you a type-safe REST client for calling microservices. So that's the kind of lowest layer, the kind of table stakes of MicroProfile for doing cloud-native services. But as I mentioned, if you're moving to a cloud-native approach and you're deploying hundreds, maybe even thousands of frequently evolving services, you've got new challenges. You've got challenges around resiliency, being able to call services, and maybe those services are temporarily unavailable and so on, and you want to handle those failures gracefully. Or you've got challenges around how you communicate between your teams. In terms of telling people how to call your service and so on. You need to be able to secure all those services, and potentially you need to be able to provide configuration to those services. So MicroProfile defined a set of specifications for doing those. So as I mentioned earlier, OpenAPI as a standard form of defining the APIs for your microservices. So rather than just telling your team, describing to them in some kind of written document how to call the service, or having to provide maybe code clients written in Node if they're going to call you from Node, or written in Java and so on, you can just give them the Swagger definition or the OpenAPI definition. Fault tolerance. So fault tolerance defines a number of resiliency approaches. So are people familiar with maybe Hystrix? Yep, a few hands there. Yep, so fault tolerance defines a number of approaches to dealing with faults. So you might want to be able to gracefully handle timeouts. You might want to use a bulkhead pattern, so you can throttle the workload that you're putting into a service because you know perhaps it can't handle high workloads. There are other patterns, and there's fallback, for example. So if eventually the service does fail, you can go and call a fallback service or a fallback method and so on. There's JWT for securing services. So this lets you flow JSON web tokens into your runtime, and then based on those web tokens, what the user and role information is, you can then secure the operations within your service implementation. So you can, if a user comes in who's in a role that isn't allowed to call a particular operation, then you can reject that request and so on. And then finally, config. So config helps you with. Are people familiar with the concept of dev prod parity, which is one of the 12-factor concepts? So what this says is, when you're doing cloud native, you're going to be automating the heck out of things, because you're rather than doing infrequent small numbers of deployments, you're going to be doing lots of deployments. So you're going to have an automated deployment pipeline, hopefully, with lots of testing as you go through. DevProd parity says make your development environment as close to your production environment as possible. So you build the thing you're going to put into production as soon as possible, and as it goes through the pipeline, you don't want to rebuild it. Because if you rebuild it, then that invalidates some of the testing that's gone before. And so with a configuration and external configuration capability, which config gives you, what you do is you build it once, and then you externalize all the things that need to change as that goes through your pipeline. So you can then inject things like port numbers or URLs and so on into the component as you deploy it into different environments. All right, so I'll just give a quick demo of OpenAPI, and I think maybe demo something else. Right. Where am I? Let's just show it first. All right. So what the OpenAPI MicroProfile spec does is it defines essentially from a Java environment how to describe microservices. This isn't being very nice to me. Let's just get rid of that. All right. And so it has annotations to define some of the OpenAPI metadata. But one of the really nice things is if you take a look at a service, so this is an example JAX-RS service, which is just going to say hello to a named person that's passed in, returning this object. There's quite a lot of metadata there already. So I don't want to have to re-describe everything in order to generate my OpenAPI or my Swagger definition for someone to be able to use my service. So, for example, I know the names of I know the name of the data structure I'm going to return. I know what properties it has and what their names are and what the types are. So there's a lot that you can get for free, essentially, out of the OpenAPI capability. So what it does is it standardizes a URL for where the information is going to come from. Where's my pointer gone? There we go. So I can go to this endpoint. There it is. And you can see why isn't that? Ah. Well, I should be able to go to that endpoint. Oh. Let's try and run that again. Nope. I seem to have broken that one. That's disappointing. Anyway, I'll move on from that one. Which makes the quiz question interesting. I suspect if I do this, it'll be fine. I think what I did is I moved something around. I did a talk last night and I demoed all of these things and they all went fine, honest.
Yeah.
They didn't video it though.
It worked.
So there's no evidence.
Yeah.
All right. I'm going to give it one last try. I'll get an A for persistence. Why isn't the pointer? Thank you. Yay. Okay, so you can see this has all come from just the Java code that you've written for your REST service. So it's got an operation. It's picked up the operation name. It knows what parameters are going to be passed in and the fact that they're required, and then it says it's going to return one of these greeting things, and it knows that that greeting thing consists of a name and a message, which is great. And what some environments give you from the OpenAPI definition is you can actually just give it a try. I really like this because when there are some environments I've tried integrating with, like Hyperledger Composer for doing blockchain things that I've had to play around with, and they produce OpenAPI definitions or Swagger definitions, and I can look at the operations and see what they are and what they return as types. And one of the really nice things is you can give them a try, so you don't have to write any code in order to try out the operations. You can learn how to use the operations, you learn how to use the API before you actually start committing any code. So we can just say let's give a greeting to DevOps UK, and you can see the response that's come back from that API. And I haven't had to write any Java client code at this point. All right. So quick quiz. A team wants to use your service and has asked you to document it. Do you see it as an opportunity to try an ASCII doc thing you heard about at a conference? Votes? Okay, thank you. Do you suggest they fire a few requests at it? And using the old Shakespeare analogy, with an infinite number of monkeys, I'm sure they'll get there eventually. Any votes for that one? And then the last one is use OpenAPI. Use the Java support because you get a lot for free, and then if you need to add any additional documentation, there's nice annotations for you to be able to do that. Votes for C. Thank you. All right. So fault tolerance. I'll demo fault tolerance. I've got a couple of demos later on, but I'm not going to show those because I think fault tolerance is probably quite an interesting one. Has anyone written any fault-tolerant applications using Hystrix or anything like that? Yeah? A few people? Cool. So you're probably familiar with the concepts then. So Steve's looking at his watch.
My phone.
Your phone.
Yeah, which is my watch.
Yeah. It's all right, I'll cut some of the later stuff.
You've got 7 minutes. No pressure.
Yeah.
No stress.
No, none at all. So what I'll do is... So, don't ask me why, but I've got two services, one called Service A and one called Service C. I don't know where B went. Maybe it wasn't fault tolerant. So I'm going to run Service C. Service A depends on Service C. And what I should have done, and I keep forgetting to do, is get the code up. So I'm going to remember to get the code up this time. And then it gets in the way. All right. And so these services just provide system properties on their API. So you request the name of a named system property. Excuse me. So, flicking around a bit, sorry about that. And also losing the pointer again. Thank you. So what I'll do is I'll go to Service C. And I need to get a property up. And the one that's most interesting is the install directory. Because that tells me, look, this is installed where the server's running is actually Service C target Liberty WLP. And I'll go and get Service A up. And you can see actually, so this one's says it's installed in Service C as well, because it's actually going and requesting from Service C the system property. So it's getting the answer back from Service C. And what I can do is the way Service C is written is it changes its behavior based on a parameter I pass in that tells it to start misbehaving potentially, so telling it to time out, or telling it to intermittently return faults and so on. And then in Service A, I can then call it, passing that parameter in to exhibit the different behaviors. And so in this helper, this is where I'm implementing or using the various different fault-tolerant capabilities. So you can see here I've got a method that's going to use retry capability from this retry annotation. I've got one that's going to use the timeout capability, so when I call the service, it's actually going to take longer than the 500 milliseconds I've defined here. So I'll time the request out and return back to the caller of Service A before Service C actually times out. I can do timeout with fallback, and here you can either have a fallback class, you could call another service. In this particular example, it's using just another operation, another method, which is actually going to return the equivalent system property, but from Service A. So what I can do is, in the client that in my implementation of Service A REST, I can change my change the method I'm going to call. Let's decide which one. So I'm going to do with no retry. And what this one's going to do is this is going to fail every alternate request, which isn't a nice behavior. And so I want to actually use the fault-tolerant retry capability. Hopefully that's the right... No, it's with retry, isn't it? And so now what I've done is I've added a retry in. So even though the service that I'm calling is going to fail every other request, I never see it in the response back from service A, because service A is just going to retry it until it succeeds. All right. Very quickly try another one. Do it with a timeout. So this one is going to pause for a bit and then fail. So we're going to time out every time. And then, is it with fallback? And fallback. Alright, so now what I'm going to do is when it times out, I'm going to call that fallback method. So it's still going to pause for a little while whilst it times out, and then I'm calling the fallback. And you see it's called the fallback because it's actually returned the system property for service A. So that's just an example of how simple it is to actually use the fault tolerance capabilities of MicroProfile to make your application more resilient. All right, I forgot 3 minutes?
4, apparently.
4 whole minutes.
You got an extra minute.
Shall we do this quiz question?
Go on then.
All right. So you're deploying microservices that depend on other teams' services and have noticed that they occasionally fail, which is causing your service to fail. Do you blame the other team because they're incompetent every time your service fails? They need to sort their act out. Yeah, I got a few for that. No blame culture. Do you hold firm? You trust that they'll fix it eventually and then everything will be fine. Okay.
Yeah, trust. Yeah.
Or do you take responsibility for your own service and then gracefully cope with the instabilities of the things you depend on? So more people went for blame.
Yeah, it was easier.
All right. So the last piece, I'm just going to very quickly cover this. I won't demo any of it. So the third part of MicroProfile, the third set of capabilities, is basically if you're deploying, again, hundreds or thousands of microservices, how do you deal with problems? How do you know when things are going wrong? How do you know when you need to scale things up better? And if you've got a request, which is what used to be within your single process, going through various components within your single process in a monolithic application, is now flowing through lots of different processes, how do you know where that's gone and what went wrong? And so there are 3 specifications that MicroProfile provides. There's open tracing, for which essentially adds context to your requests so you can trace through your system. There's health check, which lets you define in your application what it means for your application or your microservice to be healthy, because some external system doesn't know what healthiness means for your service. It might mean that I'm healthy, I'm okay if that service is down, or if what service I depend on is down, then I consider myself unhealthy because I can't function properly. So you can define what it means to be healthy, and then that health endpoint is something you can point, for example, Kubernetes liveness or readiness probes at, and then use that to then get that understanding into Kube. And then the last one is metrics. So you can get a number of metrics out in Prometheus format, JVM metrics, you can get potentially server runtime metrics, but you can also instrument your application for metrics, so you can then get information out. And you can use those metrics, for example, if you're getting heap information and CPU information out, you can start using those to help understand and scale the environment. So, no demo of health and metrics. If you would like one, I'll show you later. So, you're about to be the proud owner of a live production microservice. You like your weekends, I know I do. And you want to minimize the time spent solving issues. Do you decide it's a no-op? Because due to encapsulation, which is what microservices and things like that are all about, so the great thing about microservices is you never need to know what's going on inside. Yeah, I like your voting. Thank you. You write everything out. This is a bit controversial. Write everything to standard out, because factor 11 of 12-factor apps, go and read 12-factor. It's actually really, really good. So go to 12factor.net. So it's a little bit sarcastic. Tells you that's all you need to do. I think some of that is useful. And I don't know whether that's a serious vote, but maybe it is, and that's fine. And third one, instrument your service for health with kube probes and metrics with Prometheus, or other monitoring things are available, and use something like open tracing, Zipkin, etc. to track requests flows and so on.
Yes.
Votes, yes, great, thank you. All right, I'm going to skip the service mesh bit because we're out of time. I wanted to talk about that, but I'm going to skip that. So,
go on then.
I think this is the final quiz question.
Yeah.
So if you get this wrong, you're not allowed to leave. At least that's what we're told at work when we take these education things. So your boss asks you to recommend an open technology stack for developing and deploying cloud-native microservices. Do you? Oh, what happened to the reveal?
No.
Do you, A, recommend OpenJ9 to optimize your runtime characteristics for cloud? B, recommend MicroProfile and add resilience capabilities, monitorability, if that even is a word, security in a vendor-neutral way. C, recommend right-sizable runtime approach using runtimes that support open specifications. I prefer OpenLiberty, but other runtimes are available, to optimize your deployments to the cloud. So votes for A?
Well, actually, isn't it all of the above?
Shh, shh, shh. Oh. We didn't rehearse this. Votes for B? Votes for C? Votes for all of the above?
Yes. Thank you.
Okay, you're allowed to leave the room.
Thank you.
Thank you. If you've got any questions, come to the front.
Or not.
Or not.